4.7 is scientific notation, can be found on page 204 of your textbook. If you want to follow along, you can go to that page. Please have out a notebook so you can take notes. The first thing that we want to talk about is, what is scientific notation? And scientific notation is a way of writing a number using the product of a number and a power of 10. So this is the first thing that I would like you to put in your notes. Scientific notation is a way of writing a number using a product of a number and a power of 10. And here's an example of what scientific notation looks like. 3.8 times 10 to the 5th power. So you may be asking, why do we use scientific notation? Scientific notation is a way of writing very large or very small numbers in an easy, small format. Please enter this into your notes. Scientific notation is a way of writing very large or very small numbers in an easy format. So we are condensing when we use scientific notation. The first example I have is 28 million, and the way that this is written out, 28,000,000 is standard form. And another way to remember what standard form is that it's just numbers. Now we can take this number and we can write it as scientific notation. So the first thing that I'm going to talk about is going from standard form to scientific notation. Let's first start with the 3 steps. Here's the first step. The first step is to place a decimal in the standard form so that it has a value between 1 and 10. So if we look here at 28 million, where would you put a decimal point so that the value is between 1 and 10? Well, we'd put it right here, so it's 2.8. Step 2 asks us to count the places to where the decimal should have been in standard form. So if I look here, I'm going to go from where the decimal is now that I placed it to where it should have been, and it should have been here at the end. So we're talking 1, 2, 3, 4, 5, 6, 7. So this would be 2.8 times 10 to the 7th. And step 3 says, if the standard form was a large number, it will have a positive exponent. If the standard form was a small number, it will have a negative exponent. So in this case, 28 million is a very large number, so our exponent will be positive, and so our answer is correct at 2.8 times 10 to the 7th. Please make sure you have these 3 steps in your notebook. Here are 4 problems that we can try. This one is 5,502,000, and the first step is to put a decimal point where it would be between 1 and 10, so we're going to put it right there. Then we count the movements to where it should be, 1, 2, 3, 4, 5, 6. So this would be 5.502 times 10 to the 6th. And then you double check, is this a large number in standard form? And yes, it is. So then your exponent would be positive. 600 million. To place a decimal point so the values between 1 and 10 would be right here. And then we will count to where it should be. 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 6 times 10 to the 8th power. Number 3, where would we put the decimal so that it's between 1 and 10? Well, we'd put it right here in between the 8 and the 4. And then we count from where it currently is to where it needs to be? 1, 2, 3, and 4. So this would be 8.4 times 10 to the fourth power. And then was this a large number or a small number? Well, this one was a small number, so this would be a negative 4. And 0.00256, we would put the decimal point between the 2 and the 5. And the difference between them would be 1, 2, 3. So this would be 2.56 times 10 to the negative third, because it is a small number. To go from scientific notation to standard form, the first thing that you need to do is ask yourself, is this going to be a large number or a small number? And if it's going to be a large number, because the exponent is positive, the decimal is going to go to the right. And if the exponent is negative, the decimal is going to go to the left. So we've discovered that 5.6 times 10 to the fifth is going to be a large number. So what I would do is I would rewrite 5.6, and then I would add zeros since I know that it's going to be a large number. And you can put a whole bunch of zeros, that doesn't matter. And what we need to do is move this decimal to the right 5 places. 1, 2, 3, 4, 5. So you can rewrite it as 0, 0, 0, 0, 6, 5. Put in your commas, 560,000. All right, let's try another one of these. Obviously, this is going to be a large number because our exponent is positive. So I would rewrite this as 2.8. And then I'm going to add zeros to the right. And our decimal point is going to move to the right 3 places. 1, 2, 3. So we would have 0.0082. Put in your comma, 28,000. Okay, this is an example how we turn a scientific notation of a small number into standard form. 3.6 times 10 to the negative fifth. Well, it's a negative 5, so we know it's going to be a small number. So what I would do is I would write 3.6 and add zeros to the left. How many places do we have to move the decimal? 5 places. So we go 1, 2, 3, 4, 5. 0.00036. On your homework tonight, you'll see a problem like this that'll say, order these numbers from least to greatest. And the first thing that you need to do is change everything back into standard form. So 2.4 times 10 to the fifth. This is going to be a large number. 2.4 times 10 to the fifth, which means we're going to move the decimal point to the right 5 places. 1, 2, 3, 4. One more 0 would be like that. And so putting our commas in, we have 240,000 is the first one. Then the second one would be 3.3. Once again, we're going to go to the right. 1, 2, 3, 4. Putting in commas, this would be 33,000. And now the last thing is just to decide which one is the smallest. So the smallest is this one. So this one would go first. So you'd write 3.3 times 10 to the fourth. Then the next one would be 49,000, followed by 2.4 times 10 to the fifth. Here are 5 questions I would like you to do right now. Take out a piece of notebook paper and number 1 through 5. And here are the answers. And here is your homework for tonight. Page 206, 2 through 10 even, 14 through 30 even, 48 and 50.